Have you ever noticed that reality sometimes glitches? Small, seemingly insignificant details, the kind we usually write off as coincidence. Picture this: you're sitting in your office, just another morning with your coffee, and suddenly, you get this overwhelming feeling that this exact moment has happened before. Every single detail, down to the notification sound on your phone. Déjà vu? Maybe, but why this particular moment? And why does it keep happening more often than it should? You think of someone, and they call coincidence. But what if it keeps happening again and again? You're absolutely certain you left your keys on the table. You remember doing it, but they're not there. You check your pockets, your bag, everywhere possible, and suddenly the keys appear exactly where you've already looked. 3 times. What if these aren't system errors at all? What if this is a user interface? What if our reality is a program? Sounds like something out of a sci-fi movie, right? But let's look at the facts. In 2003, Oxford philosopher Nick Bostrom proposed a fascinating logical puzzle. If an advanced civilization can create perfect simulations of reality, which seems inevitable given enough time, then statistically, we're far more likely to be living in one of countless simulations than in the one base reality. In other words, if simulations are possible at all, we're probably in one right now. Sounds crazy? Well, let's look at some evidence that might make you think twice. When we talk about simulation theory, people often say, you'd need impossible computing power to simulate a universe this complex. But when we look at how technology is developing, things get interesting. In just 50 years, computing power has increased millions of times over. What once seemed like science fiction is now sitting in your pocket as a smartphone. And recently, we witnessed a genuine breakthrough. Google's Willow quantum processor solved a problem in 5 minutes that would take the world's most powerful supercomputer 10 septillion years. That's 1,000 times longer than the age of our universe. Yes, quantum computers are designed for specific tasks, but here's the fascinating part. They're particularly effective at simulating quantum systems. In other words, they excel at imitating the very fabric of reality at the quantum level. Coincidence? Or could our world already be running on some vast quantum computer? Today's virtual reality systems are already creating worlds that are hard to distinguish from reality. What will they be like in 100 years? In 1,000? When we look at this incredible progress, from computers that filled entire rooms to quantum processors that solve millennium-scale problems in minutes, it raises a question. If we've achieved this in just 80 years, what might a civilization accomplish in 1,000 years? Maybe our universe is too complex to simulate, but only from our current technological perspective. What if we're being simulated by a civilization whose technology is millions of years ahead of ours? It seems we can dismiss the computing power limitations. Sooner or later, the required power will be achieved. And this brings us to the most intriguing question. If this is a simulation, how does it work? And can we find bugs in its code? This is a famous experiment, but it's mind-blowing every time. Let me break it down for you. Imagine shooting bullets through 2 slits. On the screen behind, you'll see 2 clear clusters of impact marks. Makes perfect sense. But when we do the exact same experiment with electrons, something weird happens. The electrons create a wave pattern as if each electron is going through both slits at the same time. But the strangest part comes when we try to catch the electron in the act. The moment we set up a detector to see which slit the electron goes through, the wave pattern disappears. The electron starts behaving like a regular particle. It's as if reality only renders when someone's watching. Sound familiar? It's exactly how modern video games work. Why waste resources rendering what the player can't see? And here's another quantum oddity: entanglement. Two particles can instantly affect each other regardless of distance. Instantly, meaning faster than light, which should be impossible. Unless it's direct data exchange at the code level of the simulation. Take a close look at nature around you. See these recurring patterns? The same mathematical formulas show up again and again, from the structure of a tiny Romanesco broccoli to the shape of entire galaxies. Picture this, just one simple formula. If you rotate each successive point by this angle and gradually increase the distance from the center, you get the perfect pattern we see in a sunflower. The Fibonacci sequence. Simple numbers. Why does nature favor this particular sequence? Why not use something else? It's as if someone chose the most efficient algorithm and keeps reusing it over and over. These numbers define the fundamental laws of our universe. If the gravitational constant were just 1% stronger, stars would burn out too quickly. 1% weaker, they couldn't form at all. If the strong nuclear force were slightly weaker, atoms would fall apart. Slightly stronger, they couldn't form molecules. Out of billions of possible combinations of these values, our universe uses exactly the ones that make life possible. Coincidence or carefully coded parameters in the system configuration? If our universe is indeed programmed, could we already be taking our first steps toward creating our own universes? Just 20 years ago, video games looked like colored pixels. Today, they're becoming indistinguishable from reality. Modern self-driving cars drive millions of miles in virtual worlds before hitting actual roads. It's safer, faster, and more cost-effective than real-world testing. From weather forecasting to crowd behavior, modern computers are simulating increasingly complex systems, and the accuracy of these simulations keeps improving. Which raises an interesting question. If we can already create such sophisticated virtual worlds, could someone have created a simulation for us? And more importantly, for what purpose? But if we are in a simulation, can we use this knowledge? Do we have access to the system settings? If we are in a simulation, what control tools do we have access to? And perhaps we're already using some of them without even realizing it. The placebo effect is one of medicine's most baffling phenomena. A person takes a pill with no active ingredients, but firmly believes it will work, and their body starts healing itself. Pain decreases, inflammation goes down, condition improves, simply because they believed it would. But how is this possible? Why does mere belief in healing trigger actual physiological changes? Think about it. You take a pill, and your pain goes away. Seems normal, but what if that pill was just sugar? How does placebo work? And more importantly, why does it work at all? Scientific research shows the placebo effect is real and measurable. In some cases, fake medicine works just as effectively as the real thing. But how does this look through the lens of simulation theory? What if the placebo effect isn't just psychological? What if it's a hidden interface to access system settings? And it's not just medicine. Any genuine belief in an outcome can alter system parameters. Lucky charms, rituals, strong beliefs, these might all be different ways to access the same interface. Now we see, you don't need to be a programmer to access these settings. All you need is to truly believe. But there's a catch. This method only works on your own settings. Modifying parameters of other simulation participants is impossible. But this is just the first tool for accessing the system. What if there are others, like a debug mode? Most people just passively watch their dreams unfold. But there's a special practice called lucid dreaming. It's the art of becoming aware that you're dreaming while you're still in the dream. Thousands of people worldwide have mastered this technique. Imagine, you're asleep but fully aware of it. You can consciously act, make decisions, control the dream's narrative, just like in a program's debug mode, where developers can test different scenarios. Lucid dreaming is a state where you know you're dreaming, but stay in the dream. And this is where it gets fascinating. We can control dream reality, change locations, create objects, break the laws of physics. History knows many cases where complex problems were solved in dreams. It's as if the brain gains access to some hidden database that's not available in our normal state. In programming, debug mode lets you test different scenarios without risking the main program. Similarly, dreams allow us to run different event scenarios, test possible solutions, practice skills. Perhaps lucid dreaming techniques aren't just a mind trick. They might be a way to access our reality's debug mode. But there's a limitation. This mode only works in your personal dream space. But dreams aren't the only way to access the system's hidden features. There's another communication channel that works even when we're awake, something we've come to call intuition. Have you ever had that feeling that something was about to happen? A call from someone you were just thinking about, a canceled meeting you didn't want to attend anyway, a sudden urge to change your route that turned out to be problematic. What if these aren't just coincidences, but system messages we're receiving? Scientists long dismissed intuition as mere coincidence. But studies show that people often predict events with accuracy far beyond random chance. Our brain processes vast amounts of information, most of which never reaches our conscious awareness. From a simulation theory perspective, intuition might be something like system notifications. Like your email spam filter, our consciousness blocks most of these signals. But sometimes the most critical messages get through. And here's where it gets interesting. It seems we can learn to hear these messages better. Meditation, mindfulness practices, developing awareness, all of these might help strengthen the signal and reduce the noise. Placebo, dreams, intuition. We've discovered 3 natural interfaces for interacting with the system. But this might be just the beginning. How many more hidden capabilities haven't we noticed yet? How many tools are still waiting to be discovered? These tools might not be just quirks of human psychology. They could be our natural interfaces for interacting with the system. The only question is, how do we learn to use them effectively? Let's look at the facts we have. Quantum effects that resemble code optimization, mathematical patterns recurring throughout nature, the exponential growth of computing power, the placebo effect, a scientifically verified phenomenon of self-healing, lucid dreaming, a documented ability to control virtual dream space, intuition, the capacity to process information at a subconscious level. Whether we live in a simulation or not, these reality interface tools are available to us right now. We might just be beginning to understand their true potential. Maybe the real question isn't whether this is a simulation, but how to make the most effective use of the tools we have access to.